A janitor at Princeton University uncovers a crack in Einstein's field equation just as he wipes the board clean. The corridor in Princeton University's Institute for Advanced Study was deserted. The wind outside whispered through the stone walls like voices long forgotten. Room 237 stood at the end of the hallway, dimly lit, still carrying the scent of chalk and old ideas. Once, Einstein lectured here. Now, a man named Noah Reed cleaned it in silence. He was 38, with the kind of hands that spoke of years holding mops and buckets, not pens. No one paid much attention to him. He moved like furniture, present but unnoticed. Yet beneath his weathered uniform, Noah carried a secret. He loved the quiet language of physics. He read discarded textbooks at night, took notes in the margins of old printouts. In the glow of a flickering lamp behind the boiler room, he learned to speak in symbols and questions. That night, as he wiped the board in room 237, he paused. The remnants of the day's lecture still lingered in faint white strokes. One equation stretched across the board, its symmetry familiar. Noah had seen it hundreds of times. Ramunu minus 1/2 Gimunu R plus lambda Gimunu equals 8 pi G over C to the 4th times Tamunu. Einstein's field equation, the crown jewel of general relativity. Noah had memorized it the way others memorized scripture. He understood what it described, how mass and energy bend space-time, how the universe responds to matter. But his eyes settled not on the structure but on one piece of it, lambda Gimunu, the cosmological constant, originally added by Einstein to keep the universe static, later dismissed by Einstein as a mistake, then, later again, revived to explain dark energy and the accelerated expansion of the cosmos. Noah stared at it. If the universe is accelerating, why is lambda treated as a constant? His heart beat faster. He remembered reading about supernova observations, about vacuum energy, about the mystery that lambda represented. And then the question formed clearly for the first time. What if lambda is not constant? What if it evolves? He took a piece of chalk. His hand trembled. In the corner of the board, he wrote a single line. Lambda of t equals a over t, a decaying function. Suppose lambda changes over time. Then the behavior of the universe changes too. The Friedman equations would bend. Predictions would shift. Footsteps sounded in the hallway. Noah wiped the board quickly, erasing his thought. The chalk dust clouded briefly, then settled. He turned off the lights and left. Later, in his small basement room, Noah sat with a worn leather notebook in his lap. Pipes hissed above him. The radiator clanked. He turned to a fresh page. Entry 141. Dark energy as a function, not a constant. Preliminary thoughts. Ties to the inflationary epoch. Need to revisit Friedman equations with lambda of t. He drew lines, crossed them out, tried again. He did not know if what he saw had value, but something inside had stirred awake. He remembered a winter when he was 12. His mother, already sick, had wrapped herself in a blanket and read from a book about stars. Real stars, not movie stars. She had said, "Stars burn out, but their light travels. You can still see a star that died 1,000 years ago." "So the light doesn't know it's dead?" he asked. She smiled. "Light just keeps going." He underlined that line again in his notebook. Just keeps going. The next morning, 2 undergrads in the physics lounge chuckled. "Did you see the janitor in room 237? Always staring at the board like he gets it." "Yeah, guy probably thinks E equals MC hammer." Noah walked past without stopping. But he heard. And he remembered. He lingered at the back of a lecture hall, Professor Harlow stood before a crowd, gesturing to a slide. Vacuum energy, he said, is the worst theoretical prediction in physics. Off by 120 orders of magnitude. Noah leaned against the doorframe, watching, listening. Then, quietly, he walked on. That night, wiping another board clean, Noah understood something. He had no community, no colleague, no one to say whether his thought was foolish or profound. He doubted himself again and again. Surely someone had thought of this before. Surely it had been tried and discarded. But he could not find the answer, and he could not stop the question. In the silence of his work, in the rhythm of mopping floors and scrubbing chalk, a strange resolve grew. Maybe the greatest equations are not finished. Maybe even now, something had been missed. He was not ready to speak. Not yet. But he had begun to write. And when a man like Noah begins to write, the universe ought to listen. He may have seen the flaw in a century-old equation, but no one listens to the janitor with a mop and calloused hands. Noah Reed stood at the back of the auditorium, quiet and still, a mop in his hand and a question in his mind. On stage, Professor Harlow paced beneath a large projection showing galaxies drifting apart. He spoke with conviction. Dark energy, he said, is the most poorly understood force in the cosmos. Noah listened carefully. Lambda, the cosmological constant, repurposed to explain the accelerating universe. Treated as fixed. But Noah felt something else. A quiet tug, repeating inside him. What if lambda is not constant? He said nothing. He had thought it before. He had even written it, timidly, in chalk, on the edge of the board in room 237. And then he had wiped it away. Because he was not stupid. He was not naive. He knew how the world worked. Back in the janitor's closet, surrounded by cleaning rags and spare bulbs, Noah sat on a crate. His leather-bound journal rested on his knees. The sketches he made the night before were rough, uneven. He had no access to simulations, no formal background. But the structure of the idea felt real. What if lambda was a function of time? What if the expansion of the universe responded to something dynamic? The thought seemed simple, quietly bold. In a world of chalk and solitude, it made sense. He turned to page 142. The title he gave his entry was ordinary, Lambda as Time-Dependent Variable. He wrote below it, Friedman equation under flat metric assumption, substituting lambda of t as a over t. Integrate numerically. Observe late-time cosmic acceleration behavior. Compare against Planck CMB data. No confirmation yet. No access to data sets. Just intuition. His lines grew less mathematical and more emotional toward the bottom. Would anyone believe this? Would anyone even read it if I mailed it in? What is the value of thought when the thinker is invisible? Still, he wrote. Still, he searched. He remembered what it felt like the first time he shared an answer. It was 9th grade, Mrs. Hartford's math class. Noah had solved a number theory problem with an unfamiliar method. He had read about modular arithmetic in an old book from the library. The method fascinated him. It felt like a secret door into the language of numbers. When Mrs. Hartford asked for volunteers, Noah raised his hand, something he rarely did. He walked to the board. His hand shook as he wrote. He explained what he did, step by step. The room was quiet at first. Then came a snicker, then another, then a full laugh from the back row. Hartford shook her head. That is not what I taught, she said. You are showing off, not solving. Noah stood frozen. She pointed him back to his seat. He never raised his hand again. Now, decades later, the same voice lived in him. Quiet, persistent. You are showing off. What do you know, Noah? You scrub the baseboards. And yet he could not stop thinking. He began spending more time in the physics wing, not during class, but just after, when the rooms were empty but still warm with discussion. He would walk slowly past whiteboards, scanning what had been left behind. Differential geometry, tensor calculus, notations he had learned by reading old textbooks thrown out by graduate students. He took photos with an old flip phone, rewrote them later in his notebook, then tried to make sense of them. In the lounge, professors debated string theory and inflation over paper cups of coffee. Noah stood nearby, pretending to adjust a trash bin or replace a light fixture. He listened. He learned. They never noticed. He began copying parts of their conversations into his journal. Professor Lin said today that vacuum fluctuations remain the most compelling origin of dark energy, but she still has no satisfactory answer for the constant term. Professor Dorman is frustrated with the discrepancy between the Hubble constant in early universe data versus local measurements. Said it is the biggest headache in modern cosmology. Noah wondered, what if his model, simple as it was, could help resolve that? He turned the page. Model A. Lambda of t equals A divided by t. Let A be positive constant. Behavior, decaying influence of dark energy. If applied to standard Friedmann equation, expansion rate of universe slows at late times. Fits with some alternate cosmologies. Could explain observed tensions? But he was no one. He had no degree, no published paper, no faculty mentor. One night, long past midnight, he lingered near the departmental printer. A doctoral student retrieved his document and glanced at Noah with curiosity. The title on the cover read, Time-Dependent Vacuum Energy and Cosmic Fate. Noah took a breath. Excuse me, he said softly. Is that about lambda changing with time? The student hesitated. Yeah, it is. Why? Just curious. Sounds like an interesting topic. Yeah, it is cutting edge, really niche, and a ton of math, not really layperson stuff. The student gave a polite smile, then walked away. Noah nodded. Of course, math. He returned to the closet. That night he copied the paper title into his notebook, then wrote below it. I thought of this. Before today. I swear I did. But now someone else is doing it. The difference is, he will be heard. His hands trembled. In the days that followed, he grew more withdrawn, less hopeful. He continued writing, but the lines became shorter, the entries less frequent. He began to question himself. Maybe he had made it up. Maybe it was obvious to everyone else and he had only just arrived. Maybe it had already been proven wrong. Still, he could not stop returning to the board, to the idea. In the quiet of room 237, he wrote it again. Lambda of t equals A over t. He looked at it for a long time, then erased it. That night, in the flickering light of his heater, he wrote a different kind of note. If someone ever finds this notebook, I want them to know. I did not write it to be clever. I wrote it because I could not stop wondering. I wrote it because the universe asks questions that cannot be answered in silence. And sometimes, the quietest people carry the loudest questions. Emotional peak. The silence became a weight. Not just around him, but within him. A silence shaped like loneliness. A silence shaped like doubt. He felt it in his chest, where hope and uncertainty circled each other like stars caught in each other's gravity. He could not walk into a seminar and present a model. He could not submit a paper, but he could keep writing, because truth does not need credentials, it needs caretakers. He kept the chalk in his pocket now, a piece, smoothed by his thumb, a reminder. He was not ready to speak, but someday he might be. When you spend your life unheard, one voice believing in you can sound like thunder. It was a Tuesday morning when Noah Reed noticed the envelope. It had been slipped beneath the maintenance office door. No return address. Just his name, handwritten in a looping script he did not recognize. Inside was a single sheet of paper. I saw what you wrote on the board in room 237. It was erased, but not invisible. Noah's breath caught. His eyes scanned the hallway. Empty. At the bottom of the note, a name. Dr. Ezra Klein. Ezra Klein was a theoretical physicist known less for fame than for precision. He had published a modest number of papers, each marked by clarity and quiet defiance of convention. Not a headline grabber. But within academic circles, his name carried the weight of a scalpel. Clean, sharp, precise. He was also, as fate would have it, one of the few who still lectured in room 237. He had been standing just outside the door that night, late, retrieving forgotten notes, when he saw the janitor scribble and erase. Most would have ignored it. But Ezra had been raised by a librarian mother who told him, "Pay attention to the margins. That is where truth often hides." And so he remembered the man with calloused hands, the chalk dust on his cuffs, the phrase, lambda equals function of t. It haunted him for days. He searched the cleaning schedule, asked around, discreetly. When he learned Noah's name, he hesitated. Could one truly trust the instincts stirred by a fragment of chalk on an old board? Still, curiosity outweighed decorum. So he left the note. That evening, as golden twilight bled into Princeton's ivy-covered walkways, Noah hesitated outside room 237. He had spent years cleaning this room, always after the lectures ended, when echoes lingered and the chalkboards still smelled of ideas. But tonight, he walked in as an equal, at least. That is what he told himself. Ezra sat at the first row, surrounded by notebooks and an untouched thermos of tea. "Mr. Reed?" he asked. Noah nodded stiffly. "Yes, I got your note." Ezra smiled. "I appreciate you coming. I hope I did not startle you." "You did. A little. Then I am doubly grateful." Ezra gestured to the chalkboard. "I wanted to understand what you saw, what you meant by it." Noah looked down at his hands. He had scrubbed them clean, but under the nails, the day's work still lingered. It was not anything big. Just a thought. Maybe wrong. Ezra leaned forward. All revolutions in science begin with a wrong idea. Or what seems wrong. Would you show me? Noah stepped up to the board. He picked up the chalk like it was a violin bow, tentative but with reverence. "I was thinking, we treat lambda as a constant. But the universe is not constant. It expands, yes, but also evolves. What if lambda evolves too?" He began to write. "Lambda of t equals a divided by t. It is crude," he added quickly. "I know the math is not perfect. I do not have the training. But I was trying to plug it into the Friedman equations. It changes the curvature. Subtly. Slows the acceleration in long time scales." Ezra stared. Not at Noah, but at the board. "I have seen 100 papers on scalar fields," Ezra said. "Exotic matter, negative pressure, phantom energy. But what you wrote, it is—" Noah braced himself. "It is beautiful." For the first time in years, Noah laughed. A breathy, uncertain laugh. Beautiful? Ezra nodded. You are modeling a decaying cosmological constant. The shape is intuitive. Simple, like the early models of Hubble expansion. It is approachable. I thought maybe it was too simple. There is elegance in simplicity, especially when it reveals complexity. They worked through the derivations together. Ezra wrote notes. Noah pointed at things, hesitating, but always with quiet certainty. When they ran into a wall, when the math outran Noah's vocabulary, Ezra did not mock. He translated, explained. You know this, Ezra murmured at one point. You just do not know the names yet. As the sun vanished behind Gothic rooftops, Ezra gathered the papers. I would like to explore this further, he said. Together, if you are willing. Noah looked stunned. You would work with me? I would. I am. Noah hesitated. But I am just a janitor. Ezra smiled. No. You are a theorist. Who happens to sweep floors? The next morning, Noah awoke before dawn. He opened the drawer beneath his nightstand, pulled out the old notebook, the one with the frayed leather binding. He flipped to the first page. A quote, written by his mother long ago. All knowledge begins in silence and in listening. He added beneath it, Today, someone listened back. Emotional peak. Later that week, Ezra handed Noah a printout of a draft paper. The title was plain, Time-Variant Cosmological Constants in Flat Metric Universes. But in the author list, beneath Ezra's name, was another, Noah Reed, independent contributor. Noah stared at it for a long time. I do not deserve this, he whispered. Ezra answered gently, You earned it. And science is finally remembering that ideas matter more than titles. That night, Noah stood alone in room 237. The board was clean, empty. He picked up a stick of chalk, then stopped. He did not need to write anything tonight. Instead, he sat in the front row and let himself belong. Sometimes the greatest discoveries begin not with invention, but with the courage to revisit what the world believes is already complete. For the first time in his life, Noah Reed walked through the faculty wing not as a shadow, but as someone expected. It was a quiet Thursday morning. Outside, snow flurried lightly against the tall windows of the institute. Inside, the air buzzed with the faint scent of chalk, coffee, and anticipation. Ezra Klein had arranged a private session with two fellow physicists. A small gathering, informal but nonetheless momentous. They were there to listen to a janitor. Noah had barely slept. The night before, he had rewritten his notes a dozen times, not because he doubted the math, but because he doubted himself. What if he forgot something? What if he was asked a question he could not answer? What if, after everything, they decided he was simply lucky, or worse, delusional? Ezra met him at the stairwell. Ready? Noah nodded, though his palms were damp and his throat dry. I'll walk with you, Ezra said. This is just a conversation, that's all. They entered the seminar room. Dr. Maya Lin and Professor Isaac Dorman were already seated. Both were experts in cosmology, each with more than 2 decades of research behind them. Neither smiled, not out of hostility, but from habit, the way academics often carry their skepticism like a shield. Ezra introduced Noah simply, a collaborator, with an insight I believe deserves your time. Noah stepped up to the whiteboard. He took a deep breath. Then he wrote, Lambda of t equals a divided by t. He turned. I don't have formal training. But I've spent years thinking about this equation, about how lambda is treated as a constant. But if you consider cosmic time, it made sense to me that it would decay. Maya Lin raised an eyebrow. How do you model the energy density over time? Noah opened his notebook. I plotted decay curves, assumed a proportional relationship to inverse time. I adjusted it inside the Friedman equations and noticed subtle effects in long-term scale factor behavior, especially under flat metric assumptions. Dorman leaned forward. Show us. Noah's hands stopped shaking as he drew. He explained the impact of a time-dependent lambda on expansion rates. He described late-time cosmic acceleration under such a model. He did not use complex jargon, but his logic was crisp. When he paused, Ezra filled in the mathematical formalism. Maya cross-checked values. Dorman scribbled calculations. Then there was silence. Finally, Maya said, "This aligns with certain unexplained tensions in observational data." Dorman looked up. "It's crude, but clean. Very clean." After they left, Ezra and Noah sat alone. "You did it," Ezra said. Noah exhaled. They didn't laugh. No, they listened. In the weeks that followed, they continued working. Ezra requested access to computational modeling time. Noah studied from a stack of borrowed textbooks, some more than 30 years old. He found joy in footnotes, in marginalia, in diagrams drawn by hand. They refined the lambda T model. Noah suggested corrections that mirrored late universe inflation behavior. Ezra published a preprint, crediting Noah as co-author. The paper attracted cautious praise and also harsh skepticism. One journal refused to review it. Another suggested lack of academic affiliation as a concern. Noah took it in stride. "They don't know me." "But they will," Ezra replied. One rainy afternoon, while testing the model against recent Planck data, Ezra froze. "Noah," he said slowly, "look at this." A discrepancy in cosmic microwave background predictions suddenly resolved itself when using the lambda T framework. Not fully, but enough. "This could explain the Hubble tension," Ezra murmured. For a moment, neither spoke. Then Noah smiled. "We revisit the equation, and it speaks back." Emotional peak. That night, Noah visited room 237 alone. He did not bring his mop. He did not carry a notebook. He simply stood before the board, remembering the first time he dared write an idea only to erase it. He wrote again, now, but not an equation. He wrote, "Assumptions age, questions do not." Then he sat in the same seat where he once only listened, and felt, for the first time, what it meant to teach, not from power, but from truth. Some truths are not discovered, they are remembered. In the weeks after their paper was quietly posted on the preprint server, life for Noah Reed began to change, though not in the way stories often promise. There were no news articles, no sudden invitations to lecture halls. The university did not announce him in any press release. But something quieter, and perhaps more profound, was unfolding. People began to nod as he passed. Professors who once walked by without seeing him now offered greetings. Students whispered about him in hallways, curious, half-believing. Ezra insisted that Noah join him for departmental lunches. The first time, Noah sat stiffly, overwhelmed by conversations that moved too fast. But the second time, he asked a question. By the third, someone asked him one in return. But beneath the growing recognition, a new weight took hold. Expectation. Noah felt it most when he walked into room 237. It had once been his sanctuary, the place where he had dared to think. Now it held echoes of scrutiny, as if every piece of chalk he lifted came with 1,000 unseen eyes. Ezra sensed the shift. One afternoon, he found Noah sitting on the steps outside the physics library, staring at a wrinkled page from his notebook. "You're quiet today," Ezra said. "They expect more," Noah replied. "What if there's nothing more? What if that idea, lambda as a function of time, was all I had?" Ezra considered him. "Every good idea comes with the fear that it's the last. But I don't think you're done. I think you're only just beginning." Noah looked down at his notes. A single question sat in the margin. What did Einstein miss? He closed the notebook. That night he returned to the oldest entry in his journal, the one he had written after first seeing the field equation on the board. He read it slowly, underlined phrases. Then he opened a blank page and wrote at the top, Entry 154, the vacuum catastrophe. It had been mentioned in passing by Professor Harlow. Noah had heard it before, but never deeply studied it. The term referred to the greatest mismatch between theory and observation in all of physics. Quantum field theory predicted the vacuum energy density of empty space to be 120 orders of magnitude higher than what cosmological data showed. That was not a typo. It was not a rounding error. It was, as many said, a catastrophe. Noah began reading. Old textbooks, online lectures, archived notes from cosmology seminars. He copied down every equation, every failed resolution, every footnote that hinted at something more. 2 weeks passed. Ezra found him surrounded by papers. "You're chasing the vacuum energy?" Ezra asked. "It's the part no one wants to touch," Noah said. "Because it's been broken so long, people stopped asking why." Ezra sat. "Then maybe you're the right one to ask again." They reviewed every major attempt to resolve the discrepancy: supersymmetry, anthropic reasoning, renormalization tricks. Each came close. Each fell short. One evening, over black coffee in the staff lounge, Noah said aloud, almost to himself, "What if the energy isn't wrong? What if the scale is?" Ezra looked up. Noah stood and walked to the board. He drew a box. "We always calculate vacuum energy by summing zero-point fluctuations of all quantum fields. But what if those calculations assume a flat background that isn't truly flat? What if we're miscounting because we've forgotten the metric isn't static?" He looked at Ezra. "What if the problem isn't in the energy, but in the lens?" Ezra stared. Then he smiled. "Noah, you might be revisiting more than Einstein. You might be revisiting the foundations of field theory." They began again. Noah re-expressed vacuum energy density equations using a dynamic metric model. He introduced small corrections based on time-evolving curvature. It was not perfect, but it began to shrink the gap. "We're still off," Ezra admitted. "But not by 120 orders anymore," Noah said. "Just 90. They laughed. That night, Noah stayed late. Alone in the seminar room, he stared at the evolving equations, and then, quietly, he remembered something his mother had said when he was 10. They were watching snow fall through the hospital window. She had just come back from chemo. Her voice was tired but soft. "Snowflakes fall because of gravity," she said, "but they dance because of the air." He had nodded, not understanding. "It's not enough to know why something moves," she added. "You need to know how it moves. The path is as important as the force." Now, decades later, he wrote in his journal, "Maybe the vacuum isn't wrong. Maybe it's dancing, and we forgot to look at the air." Emotional peak. The following week, at an internal colloquium, Ezra asked Noah to present. It would not be public. Just 20 physicists. Familiar faces, familiar doubt. Noah wore the same shirt he always wore, neatly pressed for the first time in years. He stood at the board, heart steady. He told them about lambda, about time, about metrics that move and lenses that distort. He showed them a problem most had set aside and offered a way to begin again. Some nodded, some frowned. One whispered, "He might be right." And when Noah sat down, he did not wonder if he had proven himself. He did not ask if they believed him. He only thought of one thing. The question had been remembered. Even the smallest voice can echo in halls built to ignore it. Noah Reed stood alone in room 237. The walls were the same. The scent of chalk, old wood, and dust lingered like memory. But something had changed. He was not here to clean. He was here to prepare. Tomorrow, he would speak at the Fall Research Symposium. It was not a headline event, but it was public, open to students, faculty, guests, and among them, skeptics. Ezra had fought for the slot. A 15-minute presentation, 10 minutes of questions, 15 minutes to be heard or to be dismissed. Noah stared at the board, wrote, erased, wrote again. He had never imagined himself standing behind a podium, let alone speaking to a room of scientists who had spent decades in academia. He was a janitor, a self-taught theorist, but he also knew something now. He belonged. Maybe not through a degree, but through the quiet persistence that had kept him writing long after everyone else had gone home. He had always believed that silence was his place, that to think quietly was his role, but silence had never protected him. It had only kept him invisible. That night, sleep did not come easily. He lay awake in the dim yellow light of his basement room, the hum of pipes above him. He thought of his mother, of the way she would have smiled at this. Not surprised, just proud. She always knew he saw things differently, that he could sit in silence for hours just to ask one perfect question. He reached for his notebook and wrote, "Entry 164. Tomorrow, I speak." The next morning, Noah sat in the back of the auditorium, waiting. The speaker before him, a postdoc from MIT, presented on quantum entanglement. Polished, confident. Applause followed. Equations scrolled across the screen like code from another world. Noah watched, not intimidated, but respectful. He had learned to admire what he did not yet understand. Then came his name. Noah walked to the front. Some eyes narrowed. Some whispered. He took a breath. "Good morning. My name is Noah Reed. I work as a janitor here at the Institute, but I have also been studying cosmology for more than 10 years. He paused. Let it settle. Today I want to revisit an old question. He drew the field equation on the board. He told them about lambda, about Einstein, about assumptions, about time. He told them that what we treat as constant may, in fact, be changing beneath our feet, that sometimes the answers we need are not new. They are questions we stopped asking. He showed them how treating lambda as a function of time reshaped the Friedman equations, how it changed the curvature of the universe's expansion model, how small changes in assumption created measurable, testable results. He kept it simple, clean, precise. The hall was quiet, but not indifferent. He finished in 12 minutes, then waited. First question. Are you aware this model contradicts standard inflation theory? Yes. That is why we explored alternate early universe behaviors. It is not a contradiction. It is a reframing. Second, you used a over T. that implies a singularity at t equals 0. How do you reconcile that? By defining a threshold function that behaves asymptotically near Planck time. We don't need to redefine the origin, we need to constrain its influence. Third, why should we believe a model with no peer-reviewed support? Because it explains a tension your current models do not. And science should not be about where an idea comes from, but what it helps us understand. Fourth, have you submitted this model to any journals? Yes. The first submission was rejected due to lack of institutional affiliation. The second is under review. I believe the model deserves consideration on its merits, not my resume. Fifth, how do you handle the implications for vacuum energy predictions? By adjusting the metric, not the energy, we model the curvature over time. The vacuum doesn't change, the lens does. By the seventh question, the tone shifted. From dismissal to challenge, from challenge to curiosity. Afterwards, Ezra caught up with him outside. You were steady, he said. Noah nodded. I was scared. Everyone is. But you stayed. That matters. That night, Noah returned to his room. He opened his notebook, wrote, Entry 165. The silence was not broken today. It was answered. The next morning, an email arrived. A student. First year. He had watched Noah's talk. It read, Sir, I thought I wasn't smart enough to belong here. I saw you speak. Now I wonder if I just haven't started yet. Thank you. Noah replied, Begin anywhere. Stay curious. He printed the email and taped it to his wall. Later that week, Ezra handed Noah a copy of a journal. Inside was their paper. Accepted, printed, peer-reviewed. The name, Noah Reed, independent contributor. Noah held it in both hands. It did not feel like triumph. It felt like silence, answered at last. That Friday, he walked across campus, unnoticed again. But this time, it did not sting. It felt clean. Right. As if being invisible had never meant being small. At the physics library, he returned a stack of borrowed textbooks. One caught his eye on the shelf, an old edition of Hawking's A Brief History of Time. He smiled. That had been the first book he ever tried to understand. He flipped to the margin of a familiar chapter. Someone had written there, in faded pencil, Truth lives at the edge of understanding. He added beneath it, and sometimes, just outside the door with the mop bucket. He walked away. Emotional peak. Later that evening, he returned to room 237. Empty. Quiet. He sat in the front row. Not to speak. Not to write. But to listen. To the hum of ideas still echoing in the boards. To the memory of chalk beneath his fingertips. He had been unheard. Then doubted. Then questioned. Now he had been answered. And that was enough. Some honors are not bestowed. They're reclaimed by those who never stopped seeking. The sun rose over Princeton with quiet certainty, touching the Gothic spires in gold. Noah Reed, now a name whispered in more than just janitorial schedules, woke before his alarm. There was no ceremony, no ribbon to cut, but today marked a turning point he could feel in his bones. That morning, the Institute's main bulletin board bore an announcement, typed plainly, without embellishment. Noah Reed to present keynote remarks during the Spring Theoretical Physics Colloquium. Underneath, smaller letters read, Independent Contributor. That title, so often dismissive, now felt like defiance turned to grace. The reactions were mixed, as they always are. A few professors raised their eyebrows. One muttered, "He's not even credentialed." But others remembered. His symposium talk, his quiet answers, the subtle elegance of his time-evolving lambda model, and most of all, the way the auditorium had gone still, not out of politeness, but because people were thinking. Ezra walked beside him as they entered the lecture hall. The chairs were slowly filling. The air held that gentle tension unique to academic gatherings, part anticipation, part resistance. The old guard always watched the new too carefully. "Nervous?" Ezra asked. Noah shook his head. "No, just grateful." He stepped up to the podium. A silence fell, not tense this time, but listening. "Good morning," he began. "Some of you know me, most of you don't. My name is Noah Reed. I've worked at this institute for nearly 15 years, mostly in the shadows, cleaning, replacing bulbs, sweeping corners. But in those corners, I watched, I listened, I learned." He paused. Science, to me, was never about prestige. It was about pattern, about curiosity, about not being able to walk past a question without trying to answer it. He moved into the heart of his talk. He did not restate the lambda theory. He expanded it, introduced a second formulation, an integral-based model that built on cosmic time as a dependent variable. He showed graphs, projections, equations. He answered questions with clarity and humility. By the end, the room applauded, not politely, fully. It was a beginning, not a transformation, but a recognition. Later that week, an official invitation arrived from the University of Chicago, an offer to collaborate on a research grant. Weeks after that, the physics review letters accepted his second paper. He was listed not as independent contributor, but simply Noah Reed. One quiet afternoon, Ezra took him aside. "I want to nominate you for honorary fellowship," Ezra said. "It's not just symbolic. It means access, funding, real doors." Noah was silent for a long moment. "You think they'd allow it?" "They already are. They just don't know it yet." The official ceremony came quietly. A small hall, 20 guests, no spotlight. A chancellor read the words slowly. "For contributions to theoretical cosmology, and for reminding us that the pursuit of truth has no rank." When Noah stood to receive the certificate, he didn't feel larger. He felt grounded. He thought of the mop, the boiler room, the endless pages of chalk-scrawled journals. He thought of his mother's hands, tired but gentle, holding a book about stars. He whispered to himself, "This is for her." In the weeks that followed, Noah began to receive invitations to participate in forums, quiet roundtables, late-night calls with postdocs, informal chats in cafes near the university. His insights weren't flashy, but they were exacting. He had a way of stripping a problem to its core. He co-wrote a third paper with Ezra and a young physicist from Cal Tech, proposing a time-varying vacuum structure derived from quantum gravity fluctuations, an intersection of speculative thought and emerging data. It stirred conversation. One reviewer called it a respectful heresy. Noah chuckled at that. For the first time, he had a desk. Not in the main faculty office, but a borrowed corner in Ezra's shared lab. It held a second-hand computer, a drawer full of mechanical pencils, and his journals, now meticulously transcribed by hand into digital files. One day, a visiting professor from Europe, an expert in quantum topology, asked Noah to explain his derivation in person. Not as a curiosity, as a colleague. That evening, Alone in the hallway, Noah sat with his tea, staring out into the fading light. He pulled his old notebook from the leather satchel and turned to the first entry. Entry 001. I think I know why stars don't fall apart, even though they burn. He smiled. That line had begun it all. Emotional peak. That evening he returned once more to room 237. Ezra waited for him with 2 cups of tea. Noah smiled. I brought something. He opened a leather bag. Inside, hundreds of pages. His entire notebook, copied cleanly. I want to publish this, he said. All of it. Not as theory, as story. Maybe it'll help someone else who doesn't think they belong. Ezra nodded. It will. He added, there's a generation out there raised to believe genius wears a lab coat. Maybe it's time they saw someone with calluses. They sat together in silence, the kind that needed no breaking. Above them, the board was blank. But in their hearts, the equations still danced. Some truths don't come quietly. They demand to be defended. The invitation came wrapped in formality, but the tone was unmistakable. A panel discussion. Topic: The boundaries of scientific rigor in theoretical cosmology. Hosted by the Institute's Ethics and Research Standards Board. Among the panelists, Noah Reed and Dr. Charles Fenwick. Fenwick was no stranger to Noah. They'd crossed paths once, in the margins. Fenwick had scoffed at Ezra's defense of Noah's early paper, calling it math by mop water. His words had never been addressed directly to Noah, but they had echoed through the halls. Now they would share a stage. Ezra found him that morning outside the auditorium, fingers tight around a thermos of coffee. You don't have to do this, Ezra said. Noah shook his head. I do. Not for me. For the work. The hall filled slowly. Faculty, graduate students, a few skeptical journalists, a camera team in the back. Noah sat at the far end of the panel table, a name card in front of him. Not janitor, not contributor. Just Noah Reed. The moderator, a soft-spoken professor of logic, opened with pleasantries before turning to Fenwick. Dr. Fenwick, you've expressed concerns about the emerging acceptance of non-traditional voices in theoretical discourse. Could you elaborate? Fenwick smiled. Sharp, polished, rehearsed. Science requires rigor. It requires training. We're in danger of confusing enthusiasm with expertise. There's a difference between inspiration and innovation, and we blur it at our peril. A murmur passed through the room. Some nodded. The moderator turned to Noah. And Mr. Reed, how do you respond to the idea that credentials are the gatekeepers of scientific integrity? Noah's voice was quiet, but steady. I think credentials measure preparation, not perception, not insight, not what a person can see in the quiet. He paused. I don't claim to have all the tools, but I've used the ones I had. I didn't write my first model to impress. I wrote it to understand. Fenwick interjected, Understanding isn't enough without peer review. Noah looked at him. Peer review isn't a fortress. It's supposed to be a bridge, but too often it's built with a drawbridge that only lowers for the familiar. A professor in the audience stood. Let's speak plainly. Are you saying we should accept untrained theorists into scholarly circles? Noah looked out over the crowd. I'm saying we should stop pretending genius only blooms behind credentials. Einstein wasn't licensed when he rewrote gravity. Ramanujan learned math from a second-hand book. We remember them because someone listened anyway. The silence that followed wasn't awkward. It was contemplative. Another panelist, a mathematician from Toronto, spoke up. I read Reed's second paper. It wasn't reckless. It was cautious. Thorough. We dismissed it because of where it came from, not because of what it said. Fenwick narrowed his eyes. Are we lowering standards, then? In the name of inspiration? Ezra spoke from the audience. No. We're lifting a blindfold. Noah sat back. The discussion continued, but the momentum had shifted. The room had turned, not against Fenwick, but toward the possibility that gatekeeping had its own blind spots. Later in the hallway, after the event, Noah overheard snippets of conversation. One postdoc said to another, "Maybe we've been wrong about who gets to ask questions." Another voice chimed in, "I'm revisiting my own bias tonight." Noah stood by the vending machine, fingers resting on a cup of lukewarm coffee, feeling both exposed and affirmed. A visiting researcher from Kyoto University approached him quietly. "I used to think science was about being the first," she said, "but perhaps it's about being brave enough to ask the question no one wants to hear." He nodded, unsure how to respond. Her words stayed with him. Emotional peak. That night, Ezra and Noah walked through the campus garden. The air was cool, the leaves beginning to fall. "I didn't plan to argue," Noah said. "You didn't argue," Ezra replied. "You reminded them why we do this, what it's for." They stopped beneath an old elm tree. Ezra looked at him. "You know what's strange? You've become the most disciplined voice in the room. Because you had to be. Because you weren't allowed a shortcut." Noah exhaled slowly. "Maybe that's the point," he said. "Maybe we don't need fewer gatekeepers, just more keys." Later, in the quiet of his apartment, Noah opened a drawer and pulled out the first notebook he'd ever written in, aged pages, full of eraser marks and doubt. He added a line to the last page. "Today, I stood in front of them, not as a janitor, not as a guest, but as someone who belonged." He closed the journal gently. When you cross a boundary no one believed you could, the map itself begins to change. Spring arrived late in Princeton. The magnolias outside the institute bloomed like white flames against the gray stone. Noah Reed stood at the threshold of a new chapter, though it didn't come with fanfare, just an email. "Proposal accepted. Joint Cosmological Modeling Grant approved. Welcome to the advisory board." It was addressed to both him and Ezra. Their latest paper, co-authored with physicists from Chicago, Caltech, and Kyoto, had caught international attention, not for its glamour, but for its humility. It didn't claim to rewrite the cosmos. It asked better questions. The model, lambda T, evolved with a subtle nonlinearity, had opened a computational window into late-universe thermodynamics. What began as chalk on a blackboard now lived inside particle accelerators and observational models. Noah still cleaned sometimes. He found it calming. The quiet, the rhythm. He would sweep hallways on early mornings before meetings, reminding himself where he began. It grounded him. Ezra teased him once. "You know we can hire someone to do that." "I know," Noah smiled. "But who else will clean up after the universe?" They laughed. But beneath the joke, a deeper truth lingered. Invitations arrived now. Workshops, panels, interviews. A letter from a publisher who had read about him in a science magazine asked if he would consider writing a memoir. Noah declined. Not yet. Not until he understood the story fully himself. One day, a high school teacher from Kansas wrote him, "My students thought you were made up. A janitor who corrected Einstein. We read your paper together, even though they didn't understand all of it. One student cried. He said he might not be too poor to try anymore." Noah read the letter 3 times. That night, he opened a new journal. Entry 001. Maybe this chapter is not about proving anymore. Maybe it's about giving back. He and Ezra launched a small mentorship initiative, unfunded at first. They called it the Boiler Room Circle, after the place Noah once studied. They hosted weekly Zoom sessions with students who had no access to formal science programs. Homeschoolers, refugees, kids who worked nights. Noah would introduce them to the field equations, then ask them what they saw. Their answers astounded him, not because they were polished, but because they were brave. One girl from rural West Virginia modeled inflation with origami. A boy from Morocco emailed a 12-page hand-drawn theory linking entropy to music. A homeschooled teen from Alaska mailed him a physical model made from string and marbles to demonstrate curvature in warped space. It was raw, imperfect, and beautiful. Sometimes they misunderstood the math, but Noah remembered how he once had too. So he explained. Gently. He never corrected with authority. He guided with curiosity. That made the difference. Soon, professors from 3 universities asked to observe the sessions, not to teach, just to listen. One wrote privately, "You've built a new form of pedagogy, one where reverence for the question is greater than fear of the answer." Ezra, moved by the momentum, proposed formalizing the initiative into an open-source curriculum. Noah hesitated, not out of doubt, but out of care. He wanted the space to stay sacred, not institutional, not yet. So they documented the work, carefully, recorded lectures, compiled the questions, not answers, just questions. Noah titled the archive, "What We're Brave Enough to Ask." The project caught media attention. A documentary filmmaker reached out. She wanted to tell Noah's story. He refused at first, but after reading the transcript of a session between a 14-year-old Syrian refugee and a retired astrophysicist, he reconsidered. "Only if the focus is on them," he said. And so, filming began, not in studios, but in living rooms, in low-resolution Zoom calls, in laughter and chalk dust and pauses long enough to let wonder grow. Emotional peak. One evening, Noah sat in a cafe near the Institute. It had begun to rain. A young man hesitantly approached. "Sir," he said, "are you the janitor who wrote the Lambda paper?" Noah nodded slowly. "I suppose I am." The young man's eyes welled. "I dropped out of school, didn't think I was smart enough. But I read your paper. Then I found your first journal online. Someone scanned it. I'm applying to community college tomorrow." Noah didn't know what to say. He simply reached out and shook the young man's hand. When the boy left, Noah sat back, watching raindrops race down the window. He remembered what his mother once said. "The stars burn out, Noah, but their light keeps traveling." He whispered now, "Keep traveling." Later that week, during a guest lecture at a public library, an elderly woman in the back raised her hand. "I'm 74, she said, voice trembling. "Can someone like me learn this? I was told I couldn't do math." Noah stepped from the podium. "If you've ever wondered, you've already begun. And beginnings are powerful." The crowd didn't applaud. They rose, one by one. That night, Noah wrote another entry. Entry number 17. "I used to think the point was to be understood. Now I think the point is to keep understanding, together. The most enduring truths are whispered, not shouted, and still, they echo forever." Winter returned to Princeton with a quiet grace. The gardens lay bare beneath a powder of snow, and the halls of the Institute glowed with amber light. Noah Reed now occupied a corner office, not for status, but for sunlight. He had requested a south-facing window, something about the warmth. It had been 3 years since the night in room 237 when he first wrote a question he was never meant to ask. Since then, papers had been published, lectures had been given, theoretical models had been refined by hands far more mathematically fluent than his, yet his name remained on every one as first to wonder. But Noah was tired. Not from work, from the weight of it. The kind of quiet fatigue that settles into the bones of someone who has spent years turning whispers into declarations. The mentorship project had grown. What began as a circle of unknowns had blossomed into a global network. Students from over 40 countries now logged in every week. They had formed their own study groups, hosted peer-to-peer workshops, even translated material into over a dozen languages. Still, Noah avoided interviews. The documentary aired without fanfare. He watched it once, then tucked the USB copy into a drawer. "I'm not the story," he told Ezra. "But you lit the fire," Ezra replied. Noah simply smiled. One morning, he returned to the boiler room. It had been converted into a study space, lined with chalkboards and mismatched chairs. On the wall hung a photo of his first journal, the pages yellowed, the handwriting unsure. Below it, a plaque read, "He began where most are told to stop." That evening, as snow fell in a heavy silence, Noah taught his final session. He didn't announce it was his last. He simply opened the call, greeted each student by name, and posed the same question he once asked himself. What if the constants aren't? They answered, wondered, stumbled, reached, and he listened. Emotional peak. A month later, Noah passed quietly in his sleep. Heart failure, the doctor said. Ezra found him, notebook still open, pen resting on the page. The entry read, Entry 143. If gravity is the memory of space, then maybe love is the memory of light. The Institute held a memorial. No grand speeches, just candles and stories. A former student read aloud his first journal page. A child from Jordan recited the Friedman equation, imperfectly, but proudly. One professor confessed she had once dismissed him, until his second paper changed her entire research path. And Ezra, voice thick with grief, said only, he saw the universe not as it is, but as it could be, if we listened harder. Legacy. A year later, Princeton announced the creation of the Reed Fellowship, a grant for underrepresented thinkers in physics, open to applicants without formal credentials. His mentorship archive became a public digital library, translated into 23 languages, cited in 70 educational reform proposals, and used in classrooms across 6 continents. And every year, on the anniversary of his first journal entry, students gather in room 237. They leave one page open, one question unanswered, and right beneath it, keep traveling. I did not write this story to prove that genius can come from anywhere. We already know that. I wrote it because I believe some questions only arrive in silence, and some lights only flicker on in rooms no one else walks into. Noah Reed, the man I imagined into being, is a quiet symbol. For every soul overlooked because of the dirt under their nails, because of the wrong zip code, because their voice didn't echo with credentials or speak in the right academic cadence. And yet, they are the ones who often ask the most honest questions, simple enough to be profound, naive enough to be brave. I dedicate this final chapter to anyone who's ever stood at the edge of a classroom, afraid to raise a hand, to anyone who read in secret, learned alone, and dreamed without permission. If you've ever felt left out of the great conversation of knowledge, remember this. Truth has no gatekeepers, and light does not need permission to travel. Thank you for walking with me all the way to the last page. And if one day You find a blackboard wiped clean, with a single stick of chalk resting quietly in its tray. I hope you'll step forward and write what only you can. The author.